lunch, we have this talk. So I'll keep it as interesting as possible. Just a show of hands, how many people are data engineers here? Excellent. And how many are experimenting with large language models or Gen AI? Okay, that's significant. So I go both ways, as in I am a data scientist as well as a data engineer. And data scientists dream, but data engineers do. So the whole idea is that in the future, we will see that data scientists may potentially lose jobs, but data engineers will never, because you guys are operationalizing things, and that's exactly what we're going to talk about, operationalizing use cases. Okay. So originally the topic was operationalizing foundational models, but I thought that would be a bit too large a topic to talk about. So I added using Chiron because that's the product that I build, and my team builds rather. So I will show you how we are talking about use cases, the entire pipeline, about how these use cases are made more functional, right? And right from the point where you get the data all the way to the point where it's deployed on a specific channel. Okay. I love to add this circle to my presentations because it reminds me of a snake that eats its own tail, and that's what most of us data scientists and data engineers do. We automate everything and basically are getting rid of our own jobs, right? So yeah. All right, so let's talk about use cases first, right? So what are these use cases that are powered by foundational models? So I've taken the liberty of saying that, hey, there are a large number of use cases that involve marketing teams, sales teams, product teams, HR, IT, finance. So essentially, any team that runs a company is a part of your target audience, right? And each of these teams within a company is essentially targeting one target persona, right? For example, marketing teams are looking at leads. They want to convert leads. Sales guys are looking after their customers. They want to make sure their customers are happy. The product teams are ensuring that users are having a great time with the product. They're trying to track how users are interacting with the product, trying to make sure that it's better, right? And lastly, HR, IT, finances, which are looking at internal employees, make sure that your employees or the employees within the company are happy. And how do we do that, right? They do it through multiple products. The websites, which are the face of the company, so marketing teams essentially looking at websites as an existence. Social channels, a lot of e-commerce, everything happens on social media channels. Product teams are looking at their own SaaS products, and HR, IT, finance teams are looking at internal channels of communication. So in all these three, the main thing is foundational models will help do these four things extremely well. One, they will help handle conversations better, which are very, very relevant for marketing and sales teams. They'll help maintain relationships better. For product teams, they'll help user journeys become improved user journeys, right? And finally, for internal HR, IT, finance teams, they help internal process become better, right? Okay, so these are 4 different examples of bots that can be built on different channels, right? Each in a different vertical, each on a different channel, and they are a mixture of rules and foundational models that have been built, right? So the first one is essentially something to do with fintech, because fintech is huge right now. Like a lot of data is being generated there. The kind of funding that fintech companies are getting is huge, and you will be able to see a simple you can book a loan, right? A loan bot that can be built very easily on WhatsApp. So the main premise of this system is that nowadays people are not installing apps, right? The apps that people want to push onto your mobile phone, they're trying very hard. They spend a lot of marketing money trying to get you to install apps. But the idea is that it's easier to market a QR code than an app, okay? And therefore, a lot of intelligence and Gen AI models are moving towards Gen AI flows that are deployed on social media channels and other channels where users actually exist. So this is an example on WhatsApp. This is an interesting use case where we are dealing with healthcare. We are targeting intensive care unit doctors, right? Before you go into surgery, there are a bunch of around 80 to 90 questions that an anesthetist has to ask you before he puts you under sleep. So this particular set of, or this particular bot rather, is a thing that is targeted at nurses and doctors, not towards patients because this is filled up by doctors. And we are working with some very well-known intensivists in India to make this possible. But the idea is, what is the GenAI stuff in this? So the GenAI stuff in this is that we ask these set of questions, but then generate a summary at the end of this journey for the doctor, so that he knows what questions he's missing. Because for a anesthetist, it's very important to know what questions to ask, so that he doesn't administer the wrong set of drugs. So that is the LLM use case here. All right. The third one is, of course, on a website, retail e-commerce, where you're essentially using large language models to improve basically a new category of commerce called assisted e-commerce. Incidentally, we are also tying up with ONDC for that, so that you can even do third-party logistics and directly have it on your website and channels. And last is, of course, Instagram, where a lot of e-commerce happens nowadays. So the idea is that you should be able to look at users' comments, understand what they're saying, and then use generative AI to essentially initiate a conversation with the user instead of just giving static replies, right? So, so these are some of the cool use cases that the industry is looking at. I mean, you will see every single large company trying to create these kind of use cases, and we are going to talk about how this becomes possible as a larger scheme and where data engineering actually takes a role there. Okay, so for each one of those use cases that you saw, this is a functional schematic of how that particular use case is working, right? It starts with the data and APIs, right? I'm sure in the previous talk, you guys must have heard that they're all talking about having a lot of data. So unstructured data, that is definitely needed. But GenAI models are at best able to answer queries, but they're not very good at taking action. So inevitably, you need to integrate with some form of API. And if you're using a large number of internal tools, then you need to be able to trigger these APIs using the JSON format and then trigger these APIs, right? So you have data and these APIs. Then you have a foundational model platform. So you could be using Azure AI, you could use GCP, so on and so forth. We have our own platform called Chiron, which talks to around 22 large language models, right? So the idea is, and this is a bit of a leap or suggestion rather, that large language models are getting commoditized very fast, okay? Everybody will be releasing a large language model every other day. And each large language model will have its own strengths and weaknesses. There are already a large number of comparison charts out there which talk about how Perplexity is better, how Gemini is better, how ChatGPT is better in certain activities versus others. So because large language models are getting commoditized, it is not right for us to get tied down to one large language model. You should be able to choose amongst a plethora of models, use them for what they're good at, and then switch wherever needed. So that's what Chiron does. It helps you switch between a large number of large language models and choose them for what they're worth. Okay, once that is done, then you need a deployment interface so that it can be deployed on social media channels, web clients, interfaces, so on and so forth. So this part, that is from the part that it goes from the AI model to social media channels, that entire pipeline is where data engineering actually plays a very big role. Once that is done, and hopefully if the use case is good, you have a large number of users using it, you have a large amount of engagement, but then all this engagement needs to get aggregated back in. Now this is where, again, data engineering takes over, because as your number of users increase, the engagement increases, the interactions that they're having with your product is increasing. That needs to get aggregated, and it needs to be converted into a format that models can understand, and then fed back into your data and your APIs, right? So this last part between aggregating functions and feedback loop that we're talking about is, again, where data engineering takes over. Till then, Chiron, the first two are all hopes and dreams that data scientists have. After that, data engineers take over. Okay, cool. All right. So we talked about a rough schematic of how these use cases are implemented, right? But each of these use cases, as I showed you earlier, has an increasing stage of complexity, okay? And I have taken the liberty of breaking that down into 4 levels of complexity. The easiest one, which we talked about in the workshop earlier as well, and I think everybody is talking about in the conference, are information retrieval bots, or use cases where you're just retrieving information. So they're called Q&A bots or Q&A flows. The one after that is called action flows, all right? Action flows is essentially the case where you're using foundational models to perpetuate an action. Like, for example, booking an order, giving a recommendation, logging a ticket in Zendesk. So all these are actions. So when you are integrating large language models with some form of APIs and action flows, that's the second level. Third are called proactive agents. So in level 1 and level 2, we are talking about the user initiating an action and then the use case responding to it. But in level 3, the agent is able to take action proactively, okay? How does it do it? Here, it takes a lot of data observing user behavior across the entire platform. So it could be usage data, browsing data, user flows, so on and so forth. And using that data, which is being supplied to a foundational model, it then decides whether it needs to take an action or not. And the action could be in a form of a nudge, so on and so forth. And last but not the least, you have community building system use cases, where essentially you're saying bots talk to one another. So you have a bot which is dealing with guests in a hotel. You're having a flow which is dealing with internal sales teams. So you need these bots to share information amongst each other so that each one can benefit and the community grows. And that is level 4. It's called community building. Okay? So these are the 4 levels of complexity, and data engineers have an increasing role as this particular stage increases. Okay, cool. So does that mean that everything can be done by large language models? It's a good question. I'm not that gung-ho about it because I've been working in that field since 2018. There are a large number of limitations that large language models have. So in the end, once the hype cycle goes down, what you will see is foundational models, large language models become another tool in your tool set, and this is that tool set, okay? The first one are called deterministic flows or rule-based flows, which all of us are very well versed with, right? Your entire SaaS products, any kind of product that you build is built on a very deterministic model. That is, you're giving a fixed input, you're getting a fixed output, right? So it's deterministic, it's repeatable, it's very easy user flow. So if I'm clicking a button, I expect an output. And therefore, no training data is required, okay? This is the base level, and everybody makes sure that finally it has to come down to this because repeatability is very important. Then after that, you have classifier flows. Now, classifier flows, right before GenAI took over, if anybody has worked with RASA or similar kind of bots, RASA works on a very classifier-based approach where you're building a classifier with limited training sets, understanding what the user is saying, and then classifying it into buckets. The advantage is, of course, you can take a large amount of varied inputs, but then you have limited outputs. So in a way, you can focus the use case down. So you don't let the user get lost somewhere, okay? So that is classifier bots. Then, of course, you have LLM agents. They have a wide input and a wide output. Meaning what? Meaning that the output that an LLM gives you is not deterministic, all right? There's a probability distribution involved. That is, based on how you're prompting it, what the training data looks like, the kind of output it gives you may vary. So the predictability is slightly low. And therefore, you have tougher user flows as well, because you need to do a lot of prompt engineering to make sure that the user flow is repeatable. The main problem with large language models is repeatability. So it takes some work to get that done. And therefore, because of that, you need a lot of training and prompting as well. Okay. Now, the last group is what all use cases eventually become, hybrid use cases. Because whenever whenever a user says, take this action, that is very deterministic, you have to revert to rule-based flows. But when a user says, hey, create a summary of what I did, or what do you think, come up with an idea for a card description. All these are very creative inputs, creative use cases. In those cases, you need to move to LLMs. So eventually, you end up having a hybrid flow where you're trying to figure out which of these 3 tool sets you group together to get a repeatable user experience, which is again very conversation-driven and human-like. So using these 4 tools and the previous slide where we talked about complexity, you determine how complex a specific use case is and how you need to go about deploying it and what are the pipelines involved, so on and so forth. So I don't have the time right now to actually get into the details of these pipelines. I'll be happy to talk to you later, but I'll keep the schematic here so that you guys can look at it. Okay, so let me backtrack a bit. Before we get into the larger complexity of things, let us understand what large language models or foundational models inherently are, right? LLMs are powerful sequence learners. That's all they are. They're mugging up sequences left, right, and center. So you give it a large amount of data, they will search for sequences, and they'll make sure that they're able to learn it. And there you have a lot of statistical patterns that they deal with. So the top 3, word-level representations, contextual representations, and positional encodings. All these 3 are statistical parameters or statistical patterns that they search for in any kind of text that they are given, right? And then after that, based on how long the text is, you get sentence-level representations, paragraph-level representations, and document-level representations. So far, so good. This does not require you to do any specific data engineering because the multi-head attention networks, the transformer model is designed to understand this kind of statistical patterns, okay? But real world doesn't rarely like this. Actually, when you're looking at use cases for foundational models, you're looking at more implicit relationships, which look like this, right? You have temporal representations. So a use case of like this would be if you're trying to help farmers grow crops in India. And there you have to understand the difference between a Kharif season and a Rabi season, right? Now there it's a very implicit relationships. The name is Kharif, the name is Rabi, but there's a temporal relationship between them. That a large language model needs to explicitly understand, and that changes based on what kind of context you have. Then you have relational representations, right? So for example, if we are talking about reading The Lord of the Rings, the relationship between Aragorn and, say, Frodo, who rarely meet in the first 3 books, that evolution of that relationship is what you want to track throughout the text. So those are called relational representations, which LLMs are not very good at learning. You need to have a lot of training data in order for them to learn this. Then you have causal relationships. If I did this, then this happens. Unless explicitly given to large language models, causal representations are something that bots don't understand because there's no statistical patterns to it. There's no statistical pattern to it. They can occur anywhere in the text, or they may not occur at all. So these kind of representations are also called implicit representations. Then you have hierarchical representations, right? So if you're dealing with, say, any kind of physics book, and it has got large amount of contents, and each content has got a bunch of chapters, and those chapters have subtopics. Unless you're reading the contents page and you're putting that into the large language model, there's no way the bot or the flow will understand the hierarchical relationships that are occurring in that topic, right? So a lot of topic modeling, statistical topic modeling that we used to do earlier is required for a bot or a LLM to understand. Spatial relationships. So when I say spatial relationships, I just don't mean GPS coordinates, but I also mean if you're looking, again, if you're, I love Lord of the Rings, but so within Lord of the Rings, you have a specific places that they refer to, that is traveled from Mithril to something else. So that entire understanding of what the geography looks like is called spatial implicit relationships that a foundational model needs to understand. And this is not possible when you have limited amounts of data. Most use cases that we are dealing with will have limited amounts of data. So this idea of saying, oh, we need a large amount of training data is great, but the reality is when as data engineers, we need to put this into practice. You have limited data, so you have to work with what you have. So these kind of representations have to be brought out and given to large language models so they understand it. And finally, you have thematic representations, right? Thematic representations would be, give me all the morals that Aesop's fables have, right? So you're trying to extract the moral lessons that are there in every single Aesop's fable. That does not happen when you have limited amount of data. So again, you need to have these relationships being bought out and given to foundational models so that they can learn and give you the appropriate answers. So in summary, these are the 6 implicit relationships, and there could be more. 6 implicit relationships that large language models will not be able to understand just purely based on statistical learning. So if you're doing any form of RAG, retrieval augmented generation, because you're giving statistical chunks of code, these relationships do not show up. So you need a platform that can explicitly bring those relationships out, and how you extract it, whether you're using Spark or any Lucene or any of these big data platforms, you need to do that to extract these particular relationships. Okay. So what happens with those relationships once they're extracted? So there are 4 layers of generative AI complexity. Okay. One is, of course, foundational models. Then one level lower is fine-tuning and prompt engineering, where you're saying that I'll use foundational models, I'll give them, I'll fine-tune the last few layers. And finally, you have pipeline engineering observability, because you want to observe this. And lastly, generative AI application, where you're doing your basic retrieval augmented generation. So from the relationships that you have extracted, you can train multi-head attention. You can train the multiple heads that a foundational model has, in which you say that this particular head focuses on temporal relationships, this particular head focuses on causal relationships, and then you train your entire model. You could take the same data and give it to supervised fine-tuning. That means you're able to tell the model, hey, these are all my examples of causal relationships or temporal relationships. Please make sure that whenever a user asks you questions which are pertaining to these, you can do a good job of answering them, right? And finally, by extracting these relationships and figuring out how you're going to improve search, you can do retrieval augmented generation, advanced retrieval augmented generation, where you're not just searching based on cosine similarity that we usually do, but you're searching on more advanced things like, oh, is there a graph, index graph search, and so on and so forth. Okay? All right. How are we doing on time? Excellent. So I did not cover a lot about observability because it doesn't directly have an impact from these relationships. But there's an important part of it where I talked about proactive agents, right? Proactive agents are not just responding to queries from the data that is given to them. They're also ingesting a lot of behavioral information, okay? So for example, this particular use case is about tracking entire user behavior on a given website, feeding that entire, so this is incidentally the data of the visitors on our website, probably yesterday, right? Where we are looking at every single user journey as a 3D complex graph, okay? We're trying to figure out where they have landed, where they have come from, how much time have they waited on each of these nodes, okay? But it's very noisy, right? Then you try to filter out the noise, and you figure out what are the most busy paths that users traverse in a given website. This data is then fed to your large language models. We use advanced RAG in order to give nudges to users where they say, hey, if you're spending time on this, I will probably give you a nudge and say, do any of these use cases which I listed earlier. All right? So that's a bit on how data engineering works. So this entire pipeline is, again, built on Spark. You're running the streaming data that you have for usage, and you're pushing it into a database and getting this out. Okay. Yeah, so that's all I had in terms of the talk. I just wanted to show you guys a schematic of how data engineering is being applied for running and applying entire use cases. So that's my LinkedIn. If you have any questions, I'll be happy to answer them.